Hi, I'm Luke. Welcome back to 100 Days of SwiftUI. Today we're on day 11, Structs Part 2. Okay, I'm going to do the tests for access control. Is this Swift code valid? So we have a struct Facebook user, a private property private post, which is an array of strings, and a public property public post, which is an array of strings as well. And we have let user equals Facebook user. This is a private property, so it might need a init method. So I don't think that's valid. Yeah, it's unable to generate the initializer. Okay, we have a struct order, a private property ID, which is an integer, and an init method for the ID. And we've got self.id equals ID. That's good. Let order equals order, ID. That's a string, so that's not going to be valid. Yeah. Okay, we have a struct person with a private property social security number, which is a string, and then an init method for the social security number, and set social security number to SSN, and it's passing in SSN with a string, so that should be good. Cool. All right, we have the struct contributor with a private property name, which is anonymous. It doesn't have an init method, so I don't think that's going to be valid. Oh, that is valid. Oh, okay. Oh, probably because it's using a default string. Okay. Right, we have the struct secret agent with a private property actual name, which is a string, and a public property code name, which is a string. It's got an init method for both name and code name. Code name is a string, but here it's trying to set it using an int, so that would not be valid. Yeah. Okay, we have a struct doctor with a property name that's a string and location that's a string, and a private property current patient, which is a string defaulting to no one. And it's creating Dr. Jones with a name as a string and location as a string. This is a default value, so it shouldn't need an init method, so that should be good. Oh, as soon as it's got a private property, it can't do the default init. It's got to be set explicitly. Okay. Okay, we have a struct office with a private property passcode, which is a string, and a property address, which is a string, and a property employees, which is an array of strings. And we have an init method. It takes in a string called address and an array of strings for employees. Okay, it's setting the passcode. And it's passing these in, address and employees. So just one employee. Yeah, I'd say that looks valid. Cool. Okay, we have a structure rebel base with a private property location, which is a string, and a private property people count, which is an int. We have an initialize that takes in the location as the string and people as an int, and it sets self.location to location and self.people to people count. Oh, the variable inside is people count, but it's referring to self.people there. So that should actually be the other way around. It should be self.people count equals people. So that is not valid. Yeah. Okay, we have a structure school with the property staff names, which is an array of strings, and a private property student names, which is an array of strings. It's got an initializer. It takes in the array of strings for staff. So it so it sets the staff names to staff, and it generates an empty array of strings for student names. So that should be good. It's passing in the staff member, Mrs. Hughes. Yeah, I'd say that's valid. Cool. We have a structure customer with the property name, which is a string, and a private property credit card number, which is an int. We have an init method with name, which is a string, and credit card, which is an int. And we do self.name equals name. That's good. And self.credit card number equals credit card. Passing in an int, that's all good. And we've got Lottie equals customer. We've got name, which is name. That's good. And credit card is an int. That's good. Yeah, I think that's all right. Cool. Okay, we have a struct toy, which has a property customer price, which is a double, and a private property actual price, which is an integer. We've got an init method, it takes in the price as an integer. Actual price equals price, yes. And customer price equals actual price times 2, yes. I'd say that works. Oh, it's a double, and it's assigning an int. Okay. Okay, we have a struct app with a name that's a string, and a private property sales, which is an integer that defaults to 0. We have an init method, takes in a name, which is a string, self.name equals name, and that's got a default value, so that's going to be okay. So I'd say this is true. Cool. Okay, a couple wrong there. Okay, now I'm going to do the test for static properties and methods. Is this Swift code valid? So we have a struct amplifier with a static property maximum volume, which is defaults to 11, and a property current volume, which is an int. Yeah, I can't see anything wrong with that. It doesn't have an initializer for the current volume, but it's not a private, so I think that's okay. So yeah, cool. Okay, we have a struct question with a static property answer, which is 42. A property question text, which defaults to unknown as a string, and a init method for it takes in questions text, which is a string, and answer, which is a string. But answer there is an int, so setting that is not going to be good. It's not going to let that happen. So yeah, this is not valid. Okay, we have a struct news story. We have a static property breaking news count, which defaults to 0. A static property regular news count, which is an integer that defaults to 0 too. And a property headline, which is a string. And then init method headline, which is a string. And is breaking, which is a boolean. We've got self.headline equals headline. Yep. And if is breaking, it increases the news story breaking news count by 1. Yeah, that looks good. And we've got else news story, it increases regular news count by 1. Yeah, I can't see anything wrong with that. Cool. Okay, we have a struct marathon with the static property distance, which is defaults to 42. It's an integer. Our property name, which is a string, and a property location, which is a string. Yeah, that looks valid. Oh, it's missing the bar or let. Ah, okay. Okay, we have a struct playing cards, which has a static property deck size. Doesn't have a type for deck size, so that's not valid. Okay, we have a struct cat with a static property all cats, which is an empty array of cats by default. We have an init method, which puts cats.allCats append self. Um, I'm not sure you can just append self in an init method. Uh, I'm gonna go with no. Oh, it's because it's a constant. Okay. With a struct person with a static property population, which defaults to 0, and a property name, which is a string, and an init method that takes in a person name, which is a string, sets name to person name. That's good. And we increase population by 1 as a variable. Yep, that looks good. Ah, it's got to refer to it using the struct name. Should be person.population. Okay. We have the struct football team with a static property team size, which defaults to 11, and a property players, which is an array of strings. Yep, that looks good. Cool. We have a struct Pokemon, which has a static property number court, which defaults to 0, a property name, which is a string, a static function catch Pokemon, and it just prints court, and it's got Pokemon.number court equals 1. Yep, that's the right way to refer to a static property. So yeah, that looks good. Cool. We have a structure order, which has a static property order format, which equals a string. Looks like a 7-digit phone number. And property order number, which is a string. Um, yeah, that looks good. Yeah, that looks good. Cool. All right, we have the struct raffle, which has a property tickets used, which defaults to 0, which is an int. A property name, which is a string. A property tickets, which is an integer. And we have an init method takes in name, which is a string, and tickets, which is an int. We have self.name equals name. Yep, that looks good. And self.tickets equals tickets. That's good. And now it's trying to call it as a static property, tickets used, but it's not static there. It's just a normal variable. So I don't think that's going to work. Yeah, it's not declared as static. Okay, we have a struct Lego brick with a static property number made, which defaults to 0, which is an int. We have a property shape, which is a string, and color, which is a string. And we've got an init method taking in a shape and a color. That's self.shape to shape, yep. And self.color to color, yep. And we are setting the Lego brick static property number made to increase by 1. Yeah, that looks valid. Cool. Okay, couple wrong, but not too bad. Okay, now I'm going to do checkpoint 6. Create a struct to store information about a car. Include its model, number of seats, and current gear. Add a method to change gears up or down. Have a think about variables and access control. Don't allow invalid gears. 1 to 10 seems a fair maximum range. Okay, let's get into Xcode and start a new playground. And call it checkpoint 6. Okay, so we're going to start with a struct. And let's call it a car. So its properties, let's say these can't be changed. So model is a string. And let num of seats, which will be an int. And we want current gear. So let's say we're the only ones that can change this. So let's make it private. Current gear, and it's going to be an int. All right, now because it's private, we're going to have to create an initializer for it. Oh, so private var. Let's create an init. Do models. So current gear we're going to create, so we don't need that one. And do current gear equals. So I only got 1 to 10, so I won't do a gear 0. I'll just do 1. Yeah. Okay, so we've got 2 functions, gear up or gear down. So because we're going to be changing the value, it's going to be mutating. Let's do gear up. Okay, so we're going to check if it's greater than 10. So if current gear greater than 10. Actually, we're going to check is less than 10. We're going to change current gear. We want plus equals, change it by 1. And let's print out gear up to, and we'll print the current gear. Otherwise, we'll just print a message. Can't go higher than 10. And we want to do the same for gear down. So mutating func gear down. If current gear is greater than 1, or current gear minus equals 1 to move it down, and we'll do print gear down to, and we'll get current gear, and we'll do another else, print can't go lower than 1. Okay, let's give it a go. So we'll do example equals car, and let's do my car, do Mazda 3. Number of seats is 5, and we'll do let's just do a gear up. So example dot, actually let's do a gear down first and see what that says. Can't go lower than 1, that's good. Okay, well, let's just do 10 gear increases. So 1 to 10. Hold on. Or we don't need the number, so just do underscore 1 to 10. Example dot gear up. All right, let's give this a go. There we go, gear up. You can't go higher than 10. Awesome, I think we're done. If you want to follow along, the link is in the description. Don't forget to like and subscribe, and I'll see you in the next one.